In this lesson, you are going to learn on how to calculate the number of atoms and the molecules present in a given amount of a substance. Let us start with the first example. It states that calculate the number of atoms present in 250 grams of 1. Aluminium, 2. Nitrogen gas, 3. Aluminium hydroxide. Let us see the solution. Number 1. We are required to calculate the number of atoms present in 250 grams of aluminium. First of all, here you are required to start by finding out the number of moles present in 250 grams of aluminium. To get the number of moles is equal to the mass given over the molar mass of a particular substance. As we know, the molar mass of aluminium is 26.982 grams per mole. This is from the periodic table. So let us start. We've said that the number of moles is equal to mass over molar mass. Now it is equal to mass given 250 grams over molar mass of aluminium, which is 26.982 grams per mole. Let us compute this. After taking 250 grams over 26.982, you get 9 is equal to 9.2654 moles. Now, the number of moles present in 250 grams of aluminium is 9.2654. This is the number of moles. Now, after we have got the number of moles, let us find out the number of atoms. To get the number of atoms, we take the obtained number of moles times Avogadro's constant. So, to get the number of atoms present in 250 grams of aluminium is equal to the obtained number of moles, which is equal to 9.2654 times Avogadro's constant, which is 6.022 times 10 raised to 23. These are the atoms. Now let us compute this value. After multiplying these two values, we get the number of atoms is equal to 5.5796 times 10 raised to 24 atoms. So the number of atoms present in 250 grams of aluminium is equal to 5.5796 times 10 raised to 24 atoms. After we have seen the solution for the first part, let us go to the second part, which is to calculate the number of atoms present in 250 grams of nitrogen gas. Let us see its solution. Here, as we have done for aluminium, to get the number of atoms present in 250 grams of nitrogen gas, firstly we should find the number of moles. As we have said, the number of moles is equal to mass over molar mass. This will be equal to 250 grams over molar mass of nitrogen gas, which is 28.014. So we get 28.014 grams per mole. Now let us compute the value which is obtained here as the number of moles. After computing, the number of moles obtained is equal to 8.924241. These are moles present in 250 grams of nitrogen gas. After we've obtained the number of moles, the second step is to calculate the number of molecules. you have to note that here, as nitrogen gas is a molecule, firstly, before you calculate the number of atoms, you should start by calculating the number of molecules. Now, to get the number of molecules present in 8.9241 moles of nitrogen gas, you take the number of moles times Avogadro's constant. So, the number of molecules is equal to number of moles times Avogadro's constant. This will be equal to number of moles which we have is 8.9241 times Avogadro's constant, which is 6.022 times 10 raised to 23. These are molecules. After multiplying, we get the number of molecules is equal to 5.3741 times 10 raised to 24 molecules. Now, this is the number of molecules present in 250 grams of nitrogen gas. After that, let us find out the number of atoms present in these molecules. How many atoms are within 5.3741 times 10 raised to 24 molecules of nitrogen gas? To get that number, we have to know the number of atoms present in one molecule of nitrogen gas. In one molecule of nitrogen gas, which exists as a diatomic molecule, has two atoms, whereby we have one nitrogen and another nitrogen. When we take nitrogen plus nitrogen, it is where we get nitrogen gas as a diatomic molecule. So we have two atoms. Now, in each molecule of nitrogen gas, there are two atoms of nitrogen. So, to get the number of atoms present in these molecules which you have obtained, you have to take that number of molecules times the number of atoms in a single molecule. So, the number of atoms present in 5.3741 times 10 raised to 24 molecules is equal to these molecules times 2. When you multiply the obtained number of molecules times 2, you get the total number of atoms is equal to 1.07482 times 10 raised to 25 atoms. So, the number of atoms present in 250 grams of nitrogen gas is 1.07482 times 10 raised to 25 atoms. After we have finished our second part, let's go to the next part, which is to calculate the number of atoms present in 250 grams of aluminum hydroxide. Solution. To get the number of atoms present in 250 grams of aluminum hydroxide, also we should start by finding out the number of moles present. You have to remember the number of moles is equal to the mass over molar mass. Now, number of moles is equal to mass over molar mass. It will be equal to mass given is 250 grams. Over molar mass of aluminum hydroxide. The molar mass of aluminum hydroxide is equal to 78.003 grams per mole. Let us compute this. When you take 250 grams over 78.003 grams per mole, you get 3 is equal to 3.205 moles. Now, the number of moles present in 250 grams of aluminum hydroxide is equal to 3.205. After this step, now we are going to calculate the number of molecules present in aluminium hydroxide. You have to remember, as aluminium hydroxide is a molecular substance, we should first calculate the number of molecules. After getting the number of molecules, it is where we will obtain the number of atoms. So, to get the number of molecules present in this amount of moles, we should take the number of moles times Avogadro's constant. Now, the number of molecules is equal to number of moles, which is 3.205 times Avogadro's constant, which is 6.022 times 10 raised to 23. Now, let us compute this. When you multiply this, you get the number of molecules is equal to 1.9301 times 10 raised to 24. This is the number of molecules present in 250 grams of aluminium hydroxide. The next step is to convert these molecules into atoms. Now, to do this, you have to know the number of atoms present in each molecule. We have aluminium hydroxide. How many atoms in this single molecule? Here we have one aluminium, and we have 3 oxygen atoms. As you see, all here and outside there is 3, so 3 oxygen atoms, 3 oxygen atoms, and we have 3 hydrogen atoms. As you see, there is hydrogen and outside 3, so it is 3 atoms of hydrogen. Now, the total number of atoms present in one molecule of aluminium hydroxide is 1 plus 3 plus 3, which is 7. So we have a total of 7 atoms. This means that in each molecule of aluminium hydroxide, there are 7 atoms. So, how many atoms are there in the obtained number of molecules? You have to take that number of molecules of aluminium hydroxide times the number of atoms in each molecule. So, the total number of atoms is equal to total number of molecules, which is 1.9301 times 10 raised to 24 times 7, which is the number of atoms per each molecule. Now we get how many atoms? Let us compute. After computing, we get 1.35107 times 10 raised to 25. These are atoms. So, the number of atoms present in 250 grams of aluminium hydroxide is 1.35107 times 10 raised to 25 atoms. After this, let us go to our second example. Now, let us see the solution for this question. As magnesium sulfate is a molecular substance, we should start finding out the number of molecules before the number of atoms. Now, let us see the number of molecules. You have to know that to get the number of molecules after being given the number of moles, you should take the given number of moles times Avogadro's constant. This is equal to the number of moles given, which is 280 moles, times Avogadro's constant, which is 6.022 times 10 raised to 23. Now, after multiplying this, we're going to get the total number of molecules. Let us compute. After computing, you get that total number of molecules is equal to 1.68 8,6,160 times 10 raised to 26. These are molecules. So the total number of molecules is equal to 1.68616 times 10 raised to 26. After we've obtained the number of molecules, now we can be able to find the number of atoms. Before you find the number of atoms, you have to know the number of atoms in each molecule. When we write magnesium sulfate, how many atoms in one molecule of magnesium sulfate? We have one magnesium atom, and we have one sulfur atom, and we have 4 oxygen atoms. By counting the total number of atoms in each molecule of magnesium sulfate, we find that we have 1, which is 2 plus 4, we get 6. Now, in each molecule of magnesium sulfate, there are 6 atoms. So each molecule of magnesium sulfate has 6 atoms. To get the total number of atoms, we take the total number of molecules obtained times the number of atoms per each molecule, which is 6. Now, total number of atoms is equal to... Now, let us multiply to get the total number of atoms. After multiplying, we get the total number of atoms present is equal to 1.0117 times 10 raised to 27. These are atoms. So we may conclude that the total number of atoms present in 208 moles of magnesium sulfate is equal to 1.0117 times 10 raised to 27. And the total number of molecules present in the same amount of magnesium sulfate, which is 208 moles, is equal to 1.68616 times 10 raised to 26. Now we are through with the solution for our second example. Let us go to a third example. Our third question states that calculate the number of oxygen atoms present in 4,000 mg of barium sulfate. Let us see the solution. To get the total number of atoms, firstly, we should start by finding out the number of moles. You have to remember, the number of moles is equal to mass over molar mass. This is equal to the given mass 4,000 mg over molar mass of barium sulfate, which is 233.39 gram per mole. This is equal to, milligram cannot be used together with gram, so we have to change the unit of the mass into gram as we are given milligram. Now, you have to remember 1 gram is equal to 1,000 milligram. Now, how many grams are there within 4,000 milligram? It is equal to 4 grams. So it is 4 grams over 233.39 gram per mole. Let us compute this. When you compute 4 over 233.39 gram per mole, you get 1.713 times 10 raised to -2 moles. Now, the number of moles present in 4,000 milligram of barium sulfate is equal to 1.7139 times 10 raised to -2. After we have obtained the number of moles, Now we can calculate the total number of molecules present. You have to note that we calculate the number of molecules before the number of atoms, though we are asked the number of atoms because as barium sulfate is a molecular substance, you can't get the number of atoms if you have not calculated the number of molecules first. Now, let us calculate the total number of molecules. To get the total number of molecules, you take the number of moles times Avogadro's constant, which is equal to 1.7139 times 10 raised to negative 2, the number of moles, times Avogadro's constant, which is 6.022 times 10 raised to 23. Now, let us compute to get the number of molecules. 1.0321 times 10 raised to 22. This is the total number of molecules. Now we are through with the total number of molecules, but we are asked to calculate the total number of oxygen atoms present. Now let us find out the total number of oxygen atoms present. To get the total number of oxygen atoms, let us first consider barium sulfate. We have barium sulfate. So when you consider the molecular formula of barium sulfate, you may recognize that in each molecule of barium sulfate, there are 4 oxygen atoms. So in each molecule, there are 4 oxygen atoms. Now, if in each molecule of barium sulfate there are 4 oxygen atoms, how many oxygen atoms will it be in 1.0321 times 10 raised to 22 molecules of barium sulfate? To get that number, we take the total number of molecules times 4 in order to know how many oxygen atoms are there. So, total number of oxygen atoms is equal to, now, total number of oxygen atoms in the obtained number of molecules will be equal to the number of molecules times 4, which is 1.0321 times 10 raised to 22 times 4. Now, let us compute. When you compute, you get the total number of oxygen atoms will be 4.1284 times 10 raised to 22 oxygen atoms. So the total number of oxygen atoms in 4,000 milligram of barium sulfate will be 4.1284 times 10 raised to 22. I hope you have enjoyed the lesson. This is the end of our today's session. I welcome you in the next sessions. Have a nice moment.